Good day. Today we're going to be looking at graphing functions and transformations of those functions. Everything you see should be review, but let's see. I've went ahead and filled in these definitions about vertical shift is up and down, horizontal left and right, dilation, contraction, reflections. The one thing I want to point out about your dilations for vertical versus horizontal. For a vertical, it is going to stretch or get bigger as you go to infinity faster. It's going to contract or compress. It's going to go slower to infinity. The green pictures are examples just to show you what that means. Horizontal dilations are in respect to the y-axis though. A dilation for compression is going to be going closer to the y-axis, whereas a stretch will be further from the y-axis. All right. Now I'm going to do two of these, and I'm going to let you have time, well, you can pause the video, to do the ones and copy them down that I'm not doing right now. Anyway, for my graph, I'm going to label the points it gave me. So -4 is 1, -1 is 1, 1 is 3, 2 is -3, and 4 is 0. It gave me an extra spot here, so I picked a point that does not exist. My transformation, y or f of x plus 3, means I'm going to be shifting it up 3 units. I'm going to add 3 to my y values. So 1 plus 3, 3 plus 3, -3 plus 3, and 0 plus 3. So my new coordinates is going to be -4, 4, -1, 4, 1, 6, 2, 0, and 4, 3. And it's graphed above. All right, let's do a horizontal shift left 1 unit. F of x plus 1. So my previous coordinate was -4, 1. Now it's going to be -5, 1. 1, 2, 3, 4, 5. It's going to be -2, 1. It's going to be 0, 3. Make sure I'm right. Yep, 0, 3. 1, -3. And then lastly, 3, 0. So here's my new graph. For a horizontal translation, left 1. If I'm going to stretch it, I'm just going to be multiplying the y values by 2. So -4 is 1 times 2 for 2. At -1, it was 1, so 1 times 2 is 2. At 1, it was 3. 3 times 2 is 6, so 1, 6. 2 was -3, so it's 2, -6. And lastly, it is 4, 0. 0 times 2 is 0, so 4, 0 is my coordinate. Here is my new graph. Oh, wrong dot. If you have not done so already, I ask you now to copy the rest of those graphs down. Make sure you know how to do transformations. Again, it should be review, so I'm not really worried about it. There's the next one if you want to copy it, as well as the rules for transformations. All right, let's move on. Describe the transformations for the given expressions. By Math 4, you should very easily be able to transform a function. You should also be able to describe the transformation. So for number 1, x minus 1, this is moving it to the right 1 unit. Remember, inside of the f of x, it goes the opposite direction of what you would think. So -1 is to the right 1. All right, the plus 2 on the outside means it's going to be going up 2 units. H of x plus 7 plus 8. The x plus 7 is left 7 units. and the plus 8 is up 8 units. Lastly, number 4, negative 3 f of x plus 2. All right, the 2 is going to be up 2. The 3 is going to be a vertical stretch. By 3. And also for the answer key for the other ones, all of these are vertical dilations. Anyway, and the negative is a reflection. So it's going to reflect over the x-axis. All right. Absolute value and quadratic functions. The standard form is y is equal to a absolute value x minus h close absolute value plus k. Same transformations. Something important to note. hk is going to be your vertex. It's going to look like a V. Domain is going to be all reals, and your range for the parent function is just 0 to infinity. Quadratic, your transformation function, the standard form, y is equal to a parenthesis x minus h close parenthesis squared plus k. Once again, h of k is your vertex. It is shaped like a U, and your domain and range are the same as absolute value. I have a table filled out and a picture of both. To graph these by hand, you can use Desmos, but to do it by hand, you're going to move the vertex to begin with. So to move my vertex, I'm going to start at point 0, 0, because that's the parent function. Now let's see where to go. It says x minus 3, so this is to the right 3 units. 1, 2, 3. There to be that part finished. The end says plus 2, so I'm going to go up 2. There is the new vertex of my function. I have not put a number in front of the absolute value, therefore my slope is not changing. I am just going to draw a 1-to-1 ratio then of a V, in the shape of a V rather, for input and output. As a reminder, the absolute value is the distance away from 0. That's why it looks like a V. Negative 3 is 3 units away from 0, and 3 units is 3 away from 0. All right. Same thing for the other ones. You should very easily know that, and you have Desmos, so I'm not going to spend a lot of time graphing those by hand. Let's look at these last couple problems, and we'll be done for the day as far as notes are concerned. This section 2 says determine what transformations are occurring from the first to the second function. So you can look at the other graphs or the other answers, but let's look at number 7. Between x squared plus 3 and x squared minus 2. So between positive 3 and negative 2, it is going down. This is 5 units. The reason it's 5 is because if I take plus 3 and 1 down to negative 2, I have to go from 3 to 0, which is 3, and then the down 2, which is 5 total. All right, from x minus 3 to x plus 1. All right, so let's put this down real quick. This is right 3. This is left 1. I don't know why I just put R. Right 3 and left 1. So I'm going from the right 3 units to the left 1 unit. I know I'm moving left, and then 3 plus 1 is 4. I moved left 4 units for this transformation. All right, there's the rest. Pause it, copy them. Let's move down. I do want to point out, normally I ask you to pause it and then try them, and then I'll show you the answers later. For this should be like 90% review, very, very few new things in this. So I'm going a little bit quicker than what I would normally do in person. All right, number 4. I'm going to write the equation to describe the shift given the parent function. So my parent function of number 4 is a quadratic. Anytime you do these problems, it is my high recommendation you put y equals, you leave a space, put parenthesis, leave a space, and close parenthesis squared. This gives me room to write whatever it says. All right, the first thing, down 2 units, minus 2 at the end. Then I see it is reflecting. This means reflect over the x-axis. Okay, this is a quadratic. The only way I can reflect it is over the x, because if I reflect it across the y-axis, I'm mapping it onto itself because it is an even function. But anyway, it is reflecting. And then lastly, a vertical shrink of 1/6, minus 1/6. The only thing I need to do now is put the x inside parentheses. My equation is finished. All right, 5, this is an absolute value, so I'm going to put y equals absolute value and leave a space in between. We are going right 6 units, so I'm going to put a minus 6 on the inside, and a vertical stretch of 2. I'm going to put a 2 on the outside. That's all it says. I'm going to put my x in the center, and we're finished. All right, last one, number 6. Y is equal to parentheses squared. All right. I'm going to move it left 5/3, so I'm going to put a plus 5/3 inside. I'm moving it up 7/12. And lastly, I want a vertical stretch of 4/3. 4/3 on the outside. I'm going to rewrite that 4/3 because I don't like the way that looks there. There we go. 4/3, I put the x on the inside, and I am finished. If you have any questions, please let me know. And if not, I hope you have a great rest of your day.